Hey guys, welcome back to Organic Chemistry 101. Today's lesson will include us teaching you about addition reactions.
Now, this is not the math we're talking about where we have simple addition questions like 1 plus 1 equals 2, but complex real-life organic addition reactions. But don't you worry, we'll break this lesson down into simpler steps for you to understand.
Addition reactions work by adding atoms and breaking pi bonds. Pi bonds are basically double bonds. We're going to write a general word equation for this specific reaction. So it's going to be easier to understand in a simpler manner, and it can be used in other reactions. We're going to have an alkene plus a halogen with the catalyst of carbon tetrachloride and a product of haloalkane. So the specific reactant we will be using is cis-butene and bromine. So let's draw the structural formula with 4 carbons, a double bond on the second carbon. We want to indicate the hydrogen atoms to show that it is in cis formation. Then we're going to put the hydrogen atom on the 3D model with the blue color as an indication. The second reactant will be bromine, which is in red. Now let's indicate this reaction in the 3D model. We're going to have a catalyst of CCl4, and I didn't mention the purpose of the catalyst before, but basically it is for breaking pi bonds. So when we break the pi bond, one bromine is going to be bonded to carbon 2, and the other bromine is going to be bonded to carbon 3. The structural formula of this product is we're going to draw 4 carbons, all with single bonds. Then we're going to indicate our insignificant hydrogens, the symbols for them, and the symbols for our bromine. We have the catalyst of CCl4 to speed up the bond breaking in order for the reaction to occur faster. Then the product of 2,3-di. Remember, di is a Greek prefix since there's more than one bromine. So it's going to be 2,3-di-bromobutane. There is no cis or trans since it is single bonds, and cis or trans is only for double bonds. The reactants and products are color-coded, so it's easier to understand. I didn't mention cis and trans in the previous example, but cis and trans only applies when there's a double bond which is not on the terminal carbon, as it prevents the rotation of the atom, so it can be it has to be in a specific position. So cis is when the atoms are right beside each other, while trans is when one atom is going up and the other atom is going down. We wouldn't do cis or trans for single bonds because single bonds allow for rotation, so the position of the atom changes.
Introducing Markovnikov's rule for addition reactions. Now, moving on to the big question, where we've been all thinking of where this rule comes from and how we know when to use this in certain cases.
This rule you do have to memorize to use, but don't worry, we're going to make it simple to understand. We're going to put it into a real life example. And remember guys, you must memorize this. Okay, so let me introduce you guys to the Markovnikov's rule. Damn, that's a tricky name.
So the rule is that the hydrogen atom becomes bonded with the carbon with the most number of hydrogens. And I'm just gonna write H as in the symbol so we can save some time and make it faster. So let's see if Mark's rule applies to the reaction we did before with cis-butene and bromine. So we're still gonna have a catalyst of CCl4, and to indicate this reaction, we'll be using a different color to indicate the breaking of the pi bond. One of the bromine will go with carbon number 2 and the other one will go to carbon number 3. So don't forget to indicate the insignificant hydrogens. So we're going to leave out the hydrogen symbols to make the diagram look neater. So we're going to be indicating the 2 hydrogens from the reactions as well as the 2 bromines on the parent chain. So for this reaction, does Markovnikov's rule matter? Well, Mark's rule only applies when the reactant bonded to either an alkene or alkyne has a hydrogen bond. In this case, we have a halogen with no hydrogen atoms. So let's just write the word equation for this reaction as well. So the catalyst over with CCl4 and the butene will be joined with the dibromo. And there's no space, but it should be one word. So the general equation is an alkene plus halogen, which is going to react to form a haloalkene. A haloalkane. So therefore, Mark's rule would not apply in this reaction.
In this reaction, we are going to be using the same reactant from the last reaction, which is cis-butene, but the second reactant is going to be different. We're going to have the reactant of hydrogen bromide. For this type of addition reaction, there is no catalyst. So as I said before, Markovnikov's rule should only be considered when the reactant reacting with an alkene in this case, or sometimes in other cases, an alkyne has a hydrogen atom attached. In this case, it does. So since it has a hydrogen atom attached, we look at the 2 carbons. Both carbons have the same number of hydrogens, but Mark's rule states that the carbon with the most number of hydrogens should get the hydrogens. But carbon 2 and carbon 1 only have 1 hydrogen each. So in this case, it does not matter if the hydrogen goes to carbon number 2 or carbon number 3. But for reasons, it's going to go to carbon number 3, and bromine is going to go to carbon number 2 by breaking the pi bonds. So the product you are going to form is a butane. Then you're going to draw your insignificant hydrogens, then your hydrogen and bromine. And I'll explain later why the bromine going to this carbon or this carbon does not matter. So let's write the word equation. So it's going to be cis-butene and hydrogen bromide. Again, there is no catalyst. This is going to be forming the product of 2-bromobutane. In this reaction, it doesn't matter if the hydrogen goes to carbon number 3 and if the bromo goes to carbon number 2, because there is a rule that the branch should get the lowest number. So if you number the parent chain from left to right, right now the bromine is on the second carbon. If it was on the carbon where the hydrogen is bonded to, if you number from right to left, then it would also be on the second carbon. So in this case, it doesn't matter if the bromine and the hydrogen were flipped. But does the Markovnikov's rule matter? Not in this case. It doesn't matter which carbon the hydrogen atom gets bonded to, as the two carbons forming the double bond have the same number of hydrogen atoms attached. Let's do a reaction where Mark's rule is explicitly shown. For example, we'll have butene with a double bond on the terminal carbon this time. Here we have two insignificant hydrogens, and they'll be bonded to hydrogen bromide. There is no catalyst for this type of addition reaction. Indicate the hydrogen symbols for either carbons forming the double bonds. We'll be breaking a pi bond. As mentioned before, we're using Markovnikov's rule, where the reactant that has the most hydrogen bonds will get the hydrogen. As there's a saying, the rich get richer. Carbon 1 has two insignificant hydrogens, while carbon 2 has only one insignificant hydrogen. So in this case, carbon 1 has the most insignificant hydrogens. So the hydrogen will bond to carbon number 1, while bromine bonds to carbon number 2. Therefore, the product is going to be 2-bromobutane. Let's keep out the other hydrogen symbols that are not involved in the reaction to make the structural diagram look more neat. Let me just erase that line. So the bromine is going to go to the carbon instead of the hydrogen, because that would look more like a substitution reaction. So the general word equation for this reaction is butene. There is no cis or trans due to the double bond being on the terminal carbon, plus hydrogen bromide forming 2-bromobutane. So it's an alkane. And then this is following the general equation. Does this follow the Markovnikov's rule? Yes, it does, since the hydrogen was forced to bond to carbon number 1, as it had the most number of hydrogen atoms attached. A popular saying to remember Markovnikov's rule is the rich get richer while the poor get poorer. So what does this mean?
So basically, the carbon with the most number of hydrogens keeps on getting the hydrogens instead of the other carbons.
Okay, so we're quickly going to go over what we learned in this video, starting off with what is an addition reaction. It is breaking of pi bonds and adding an atom or a group of atoms. The next thing we learned is about cis and trans. Cis is when the atoms are right beside each other, and trans is when one atom is going up and the other atom is going down.
And the third thing that we learned in this video was Markovnikov's rule, which is that the hydrogen atom becomes bonded with the carbon with the most number of hydrogens. Thanks for watching!
We'll see you next time.